Hello everyone, welcome to the latest lecture session. Let's get this started by looking at what we discussed in the previous session. In the previous session I was trying to take us through why it is that this course is relevant to humanity at large and then in general Indians, I guess, right. So, the relevance was that we are going to look at how to save lives or prevent unnecessary deaths, and in that context we looked at how people first did not know that pathogens existed and that we can act as carriers of diseases, or let us say the doctors could act as carriers of diseases, and that the disease does not transmit from or through air, or can, let us say, transmit through air, but one of the major routes of transmission is by contaminated water, let us say, right. And this contaminated water will look clear, but we do know now that we can look at or visualize these microbes only under a microscope, let us say, right. So, that is something that we looked at, and we started looking at some data, right, where we have numbers of typhoid cases per 1 lakh population. This is Philadelphia 1890 to 1935. We saw with increasing urbanization, increasing numbers of cases of typhoid, and then based on trial and error people figured out that filters or sand filtration could lead to, or leads to lesser number of cases. So, they started using filters, and you see that Philadelphia great drop, and then again by trial and error or such, people understood that chlorination was leading to lesser number of typhoid cases and thus number of deaths. So, again after chlorination, so much further decrease, let us say exponential decrease, that is something that you can see out here, and that is what we see out here, right. So, what do you expect now? Lesser number of, again typhoid is one particular waterborne or water communicated disease, I guess, right. So, most of these diseases, cholera, typhoid, and those that typically end up in diarrhea, let us say, what happens now, typically you have these particular pathogens, and let us say if I have it and my feces contaminates the drinking water of that locality, obviously all the people in that area are going to be affected by the disease that I had, let us say. And in the particular case in London, a particular child's diaper was washed into that cesspit or the septic tank, and that particular water was contaminating that area, let us say, and that is how it goes on and or is transmitted, let us say, right. So, again people first were not willing to take that at face value, because the thought of drinking water that is being contaminated by human feces was too harsh for people, let us say. Again, that is something that we see even now, but we will look at that again later, let us say. So, here with this advancement, let us say, this advancement meaning sand filtration and disinfection by chlorination, let us say, right, Cl2 or HOCl. So, we say that it is supposed to lead to lesser number of water or those diseases that are borne by water, and thus number of cases, and thus the mortality should decrease. Let us look at what we have here. Here we have life expectancy, this is in the USA. So, it is at birth, meaning at birth, let us say the infant, how many years can he or she be expected to live, let us say. So, this is in blue. And then we have another metric. So, at 60 years, how long is it supposed to, is he or she typically going to live. But here I try to tweak the data so that I can compare it. For example, at birth in the year 1900, 50 was the average life expectancy at birth, let us say. But at 60 years, so 60 minus 74, it was supposed to be 14. But for comparison I increased it by 60 years. So, at 60 years the life expectancy was 14 years, right. So, or the person would be expected to live to 74 or 75 years, let us say. So, why is this gap here? It means that obviously there are a lot of people dying, or not people, let us say infants or children dying during their nascent stages of life. Why is that again? Typically due to these particular diseases or such that we are experiencing in India right now. So, that is why we see this considerable difference, let us say, in the year 1900, but again the difference was almost 25. By 1950, let us say, the difference came down considerably, as in life expectancy at 60 years also increased, but only slightly, because medical advancements at that time were not very great with respect to the elderly population. But with the advent of disinfection and sand filtration and different levels of sanitation, we see that the life expectancy at birth jumped from 50 to almost 70. So, that is an increase of 20 years in life expectancy. But still there was some what do we say, there was still some difference between the life expectancy at birth 70 and life expectancy at 60 years. So, at a person at 60 can be reasonably expected to live for 17 more years or reach the age of 77. But as you see, advancements were decreasing the particular what do we say, difference here, right. And then by 2000 or early 2000, we see that there is considerable or relatively some increase in the expectancy at 60 years, but now the expectancy at birth, which is 80, is almost the same as the expectancy at 60 years, let us say, right. So, what does that tell you? That over time, especially within the first half century of the 20th century, meaning 1900 to 1950, they were able to bring down the death rate among children, let us say. Why or how? What was the major reason? It was due to sanitation and disinfected water, right. That is the primary reason that drove this particular life expectancy. Again, life expectancy, let us say, again leads to relatively more thriving economy too, right. Otherwise, the you have a sick populace, typically the economy does not do as well. So, let us look at it by comparing the data from India too. So, here we have, or I have the data from both USA and India, and I tried to see to it that USA blue colored, India green colored data sets, and then at birth the square shaped legend, right, at birth, and circle is the one at 60 years. So, as you see in India in 1900, let us say, our life expectancy at birth was abysmally low, 24, while in the US, which was already a relatively developed country by that time, it was what is it now, 50 now. So, all the people who keep talking about all the good that the British have done in spite of the facts or data, this is one more set of data out here. Again, let me not go into other details here. So, again life expectancy was remarkably low, and by the year 1950 it increased slightly, but not drastically. You can see the difference in slope here, I guess, right. You can see that difference here, right. For example, here it is 20 points or 20 years, and here it is what is it, from an abysmally low value it is still to a low value, 12 years increase, I guess. And I did not find or could not find the data for life expectancy in India at 60 years for the years 1900 and 1950. But since then, after independence, we had a considerable what do we say, increase in life expectancy at birth. That is because, I guess, people now think about themselves, and we had relatively good what do we say, administrations over the year, considering different aspects, let us say that we were at war and we were facing food shortages and so on and so forth. We see that it is almost how much is it now, 30 increase, I guess, or 27 years increase within this 50-year period now, right. So, that is a remarkable increase, and we see that in 2000 though we still have a considerable gap between the life expectancy at birth in India at 26 and at 60 years, which is 76, let us say, right. So, we still have what is it, I guess, 13-year difference. So, we still need to catch up, but we are on the right track. But the aspect that we need to note is that diarrheal diseases or such, they can be eliminated relatively easily, but lack of awareness and obviously sources of energy. Why sources of energy? Why do I say so? Because let us say if you boil the water, let us say for the right amount of time, I think 1.5 minutes at the boiling temperature around 100 degrees centigrade, you are going to kill most of these pathogens. But you need energy to boil them, and people need time, let us say, and the resources obviously, right. So, lack of such what do we say, good sources of drinking water, lack of awareness, and lack of sanitation, as in hygiene, let us say, feces, if we do not wash it properly, you have the carriers, not carriers, pardon me, the diseases on our particular hands, let us say, and we act as carriers, either we eat or we help in transmission. So, that is the reason why, I guess, we always need to wash before we eat, or hold the utensils and such, let us say. Again, something that we see out here, as in we were pretty poor at one point in time, and also that was the reason why our grandmothers, great grandmothers or great grandfathers, let's say, they used to try to have what we say large family. Why is that? The life expectancy was very low. So earlier you would have heard of people giving birth to 10, 12 children, let's say, but only 4 or 3 survived, let's say. But again, slowly but surely, as the life expectancy increased, the number of what we say children that were being produced by a particular couple, let's say, kept on decreasing. And now I guess it's at what we say replacement levels of 2.1 or 2.2. But again, because of this increase in life expectancy, we see a boom in, or we saw a boom in what is it now, population or explosive population growth around this particular period. But again, that's due to the increased what do we say life expectancy. Obviously, everything can't be ascribed to only good water or sanitation and hygiene. Obviously, people were what do we say suffering from famines and such. That was cut down upon. Relatively better food was made accessible, and obviously that also leads to what is it higher life expectancy, right? And now let's move on. So here I have some sets of data that I want to share with the people here. So we have this water quality report or water quality analysis report from Joshimath, Uttarakhand. That's where Roorkee is. Relatively lower reaches of Himalayas, where the surface water is relatively pristine. The data report was from 2019. Here we have the different units typically for which we are typically concerned, at least with respect to drinking water, right. So what do we have? Odor agreeable, but rarely do we really look at that. Okay, pH 8, because it's the mountain reaches, that's why it's relatively higher. So it's within the acceptable limit. Turbidity, meaning it will give an idea about how many suspended particles there are. For example, if I take some mud and put it in a glass, what do we say, water, water that's held in glass, let's say, and I am going to put some mud in it. I see, with turbidity or the suspended matter, let's say, right. Some of it will settle down, some of it will be suspended, and I can measure that by turbidity, let's say. That gives you an idea about the suspended matter. And total solids, let's say, total solids meaning is equal to total suspended solids, which we just discussed about, and also total dissolved solids, as in when I say dissolved solids, I guess it's self-explanatory. Let's say if I take water in a glass, what is it now, in glass, let's say, right, and I put in either salt, or if not remarkable amounts, let's say a spoonful of salt, and stir it, the salt is not going to settle down, it is going to dissolve. Same case with sugar or some such compounds, they dissolve, let's say, right. Obviously at a certain threshold, that's with respect to the solubility product. So TDS, let's say, total solids and total dissolved solids, let's say. Obviously there will be some errors, that's why you see some variation. So chlorides, we are concerned, hardness in the units of calcium carbonate, sulfate, nitrate and alkalinity, this is what we are typically concerned with. And typically, as you see, almost all of the parameters are relatively low or pretty good. Again, hardness, I guess, with respect to deposits, or the water would have what we say come across or come in contact with calcium or lime deposits. That's why seems like hardness is almost at the limit. But other than that, you see that it's pretty good, right? So that's something that you have. And here we have the Indian standards for drinking water. That's something we will look at later. BIS 10,000 or 10500. And again, one aspect I would like to point out is that acceptable limit is out here, and permissible limit in the absence of alternate source is also mentioned. And one aspect I would like to point out is that total dissolved solids, we allow it to be as high as 500. That should not create issues. Too high and you are going to have digestive tract related issues and such. And too low, which is what most people are drinking now, because most of the relatively affluent families are using reverse osmosis based water treatment units, and obviously there the TDS is going to be very low, 10 or so. And if you are not having recycle or such or bypass, pardon me, you are drinking water that's very low in the what we say dissolved salts or dissolved solids, which are actually beneficial to health. You need chloride, sulfates and so on and so forth at some levels in our body, but we are depriving of our body by I guess spending money. And then Joshimath is somewhere out here, let us say. Further downstream I guess we have Rishikesh, but still relatively pristine. Let us say we are now looking at Ganga surface water body, the data is from November 2018. So what do we see again? pH relatively less, turbidity is slightly higher compared to Joshimath. Total solids again I guess in the same range, total solids and dissolved solids. Others two are in the same what do we say range more or less, right. But one aspect that pops up here is that we see that what is this now, total coliform, which gives us an idea about contamination by fecal matter, human feces, let us say, right, is not 0. But what is the requirement with respect to drinking water? It has to be 0, but it is 26. Why is that, and what does that indicate? Why I guess is that you have you could have what do we say sewage from Rishikesh flowing into Ganga. Also you have people taking a bath in Ganga, right, because it is considered pure and that it is going to wash away the sins, right. So people take a holy dip in Ganga in Rishikesh. So that could be the reason how we have contamination of the relevant water there with fecal matter. But obviously this is one way or where transmission of the relevant pathogen takes place, right. So this water is not fit for drinking, but all the other parameters are fine, but this water is not fit for drinking because of the pathogen count, right. So the coliform count will be exponentially high obviously during religious festivals when people bathe in the river. For example, we have different Kumbh Melas and such, and once a year we have different religious processions out here where people come, take a dip in Ganga, take the water and go back home, and during that time I am sure you are going to have remarkably higher coliform levels there. And I wanted to compare that to groundwater from a village near Roorkee, okay, and again the data is from a month ago, let us say October or I think September 2020, let us say. Why are we looking at this data? Because typically in India, let us say, a lot of people use groundwater and they think that it is pretty clean, let us say. Why? Obviously because it looks clear, smells fine, let us say. Let us look at this out here. So parameters: total solids, total dissolved solids high but not very high. Hardness is high, yes, that was an issue that was leading to considerable digestive tract related issues and some joint related pains to the local population of that village. And alkalinity is high, but typically that is not of great issue. Sulfate and sodium is also relatively what do we say low, right. And then with respect to coliform though, keep in mind this is groundwater and I think they were pumping the water up from 120 feet, let us say. And another one we are going to look at is from 200 feet, right. The coliform value is 1600 most probable number. This is called most probable number, 1600 per 100 ml sample. And what is the standard for drinking water? It is supposed to be 0. And how is this occurring now? Before we go further discussing the relevant reason, let me also look at the second sample which was collected from 200 feet. So pH, TS, TDS fine, TDS slightly high, but hardness is still high as you can see, others are okay. Alkalinity is not of great issue in general, but again we see that coliform contamination at relatively shallow depths, greater contamination as high as 1600, and at relatively greater depths we see relatively less contamination, 40. Again most probable number, MPN stands for most probable number per 100 ml sample, let us say. Again how is this being contaminated? This meaning groundwater being contaminated with human feces or such, let us say. How? Obviously because we are going to have, at least in the villages and most of the even the urban areas, you are going to have septic tanks that are nothing but crude pits, let us say, right. Septic tank supposed to have some certain design. Maybe we might look at it during this during the course of this class. But again in these villages or in most of our areas, people with half knowledge, which is pretty dangerous, are going to build these septic tanks and they have no what do we say impervious layer or such at the bottom or maybe even the sides. So you have all the sewage being from the homes accumulating there, and that is going to leach into the ground, right. For example, you have septic tanks out here, and I would have loved to have nitrate and NO3, I should have collected that, but I did not do that. Maybe next time. I have all the sewage out here. So because there is no such what do we say impermeable layer, this contaminated or the sewage is going to go out here, and if the groundwater table is out here, as in if the porous layer is out here, that is where you will have the groundwater, and the sewage is going to go down and contaminate this groundwater, and people are, and if the groundwater is in this flowing in this direction, now you have human feces contaminated groundwater being pumped up and then being consumed by the relevant local population. So, in this context I want to discuss one aspect that the relevant project assistant raised. He mentioned that he saw a particular documentary where, I mean, he was the person who collected this sample and got it analyzed in our labs, and when he was looking at the data, he was wondering about why this is an issue. The reason why he was confused was that he saw a particular documentary and where a person living near Varanasi or such was fine when drinking the water from the river or from the vicinity of that particular river, Ganga, but a foreigner who came and drank that water immediately fell ill, and our project assistant thinks that we are if not a better race, we are, I guess, a healthier race, and thinks that why are we concerned about this coliforms or such. But as we just looked at the data, let us say, shows us that there are a lot of deaths with respect to the age group 0 to 5 and 5 to 14 due to diarrheal diseases, let us see. And again, diarrheal diseases typically due to contamination of water by human feces. So, let us say if I survive, let us say, or if my child or your friends survive during that period and then make it to the next stage, maybe they will not be affected by that particular pathogen or such, but typically you will keep having episodes from time to time, let us say. But here it is not, we can't make such simplistic comparisons based on one particular observation, because we know from the data that a lot of the susceptible population is still dying, let us say. Susceptible meaning the ones that are still yet to develop their own immune systems or such, let us say, right. I guess that is a layman's term. So, we have children dying out there in lakhs every year, and again, why is that? Because of diarrheal diseases. It is not as if Indians by themselves are remarkably better off race or such. We are experiencing different issues or health issues every time. So, that is what we have out here, and the western population, they are not experiencing it or used to these pathogens anymore. So, when they come in contact with these pathogens, yes, they might be relatively more susceptible, but please note that the chances of them coming in contact with these pathogens are almost nil because of sanitation and clean and disinfected drinking water, right. So, that is something to keep in mind. And let us move on out here. Yamuna though, why Yamuna? I guess it comes through the national capital region, Delhi. It starts at around Dakpathar, then flows through Haryana and then Delhi, and Delhi again, 1 crore or 1.5 crore population NCR region. And let us look at what we have. We have samples collected in October, November and December, let us say, and this is the winter period out here, at least from November, winter period. Fecal coliform, which gives us an idea about the contamination or level of contamination of the water sample by human feces, let us say, right. Fecal coliform, this live in the guts or the intestines of warm bodied animals. So, we have a Nizamuddin bridge where typically we have a lot of pollutants accumulating out there, and both upstream and downstream, or maybe my assistant messed up the data. Anyway, we see that the coliform count is remarkably high, right, and that tells you about the level of either partially treated or untreated sewage coming into Yamuna. Why is this an issue? Obviously, again, you have contamination of the groundwater, you have people depend upon it for either daily activities, if not drinking water, or if not for a source of drinking water and such. So, you as a water or wastewater treatment expert will now be able to better explain, or when you at least take up your job as any other either civil engineer or any other job, you will at least be aware and be able to take part in hopefully arriving at the right decision, let us say. So, that is the reason for offering this course, and with that I will end today's session, and in the next session we will look at the outline and see what it is that we are going to discuss. But in general, as I mentioned, we are going to look at wastewater treatment and water treatment. Again, I thank you for your patience.